Okay, final exam, day one, review A. Our first problem is a rational equation. So we want to solve this by clearing out those denominators. In order to clear the denominators, I am going to multiply this entire function by the least common denominator. To recognize what that least common denominator is, notice I'm factoring this first denominator. This x squared minus 9, that's the difference of two squares. It's equivalent to x minus 3 times x plus 3. So that is my least common denominator. That's going to take care of all the denominators I see in this equation. I'm going to multiply the whole equation by this value. I'm not building common denominators. I am canceling denominators. So I'm going to write this out nice and long so you can see exactly what I'm doing. Here's my first fraction with a factored denominator, and I'm going to multiply that by x minus 3, x plus 3. And you can think of that, we're multiplying by that over 1, because that's a whole number. That's not a fraction. Then my second fraction is 2 over x plus 3, and I also have to multiply that by that common denominator. Have to multiply everything by the same thing to keep that equivalency that I had to begin with. And my third fraction, I'm also going to multiply that by that common denominator. When I do this, when it's all written out like this, then we get some really nice canceling going on. Here, the denominator cancels entirely with what I multiplied by, and I'm just left behind with 4x minus 5. Then I have that equal sign. In my next part, the x plus 3's cancel, and I'm left with just 2 times x minus 3. And then don't lose that sign, it's minus, and here it's the x minus 3's that cancel, so I'm left with minus 7 times x plus 3. This is now an easier solve. I can solve this. I need to go ahead and distribute on the right-hand side. So I have 2x minus 6. Be careful, we are distributing a negative 7 here, so watch your signs. It's minus 7x minus 21. Then I'll combine my like terms over here on the right. 2x minus 7x is negative 5x. Negative 6 minus 21 is minus 27. Then I'm going to go ahead and start moving some things around to gather up my x's. I'm going to add that 5x to both sides. So my x's will be on the left, and then in the same step, I'm also going to add 5 to both sides to move my constants over to the right. That leaves me with 4x plus 5x, 9x on the left equals negative 27 plus 5 is negative 22. Divide both sides by 9. And there we go. We end up with x equals negative 22 over 9. That doesn't reduce, so we're going to leave it just like that. The one thing that we should check on, make sure that answer doesn't give us any zero denominators in our original equation. I can see that the value that would have given us a zero denominator is either positive 3 or negative 3. This is not either one of those, so that is our solution. We're good to go. Next up, number 2. We have a grocer who's making a little snack mix here. They're mixing peanuts together that cost $1.46 a pound and walnuts that cost $2.66 a pound to make 100 pounds of a mixture that costs $1.94 a pound. How much of each kind of nut is in that mixture? So we want to know, here's our question, how much of each nut? So that's where I'm going to set up my variables. X is going to be the pounds of peanuts that we're using in our mixture. We know that we need 100 pounds of the total mixture. And that means our amount of walnuts is going to be that total amount minus how many peanuts we put in. And that's going to tell us how many pounds of walnuts we need. Okay, so this is kind of our setup. What we're going to do then is we are going to figure out the price per pound times the amount of each item. So peanuts are $1.46 a pound, so $1.46 times X plus walnuts are $2.66 a pound, and we have 100 minus X pounds of walnuts, and that's got to equal our total mixture is $1.94 a pound times 100 pounds of that total mixture. Now that we have our equation, we're ready to solve. I'll distribute here, so I get 266 minus 2.66x. Go ahead and multiply it over here on the right. We get 194. We're going to combine these two like terms right here. 146 minus 266. 146 minus $2.66 is negative 1.2. Probably could have done that in my head. And I'm also in that step going to subtract this 266 over. So 194 minus 266 gives us negative 72. Then our last step, we're going to divide both sides by negative 1.2. And negative 72 divided by negative 1.2 gives us an answer of 60. X equals 60. Now we have a word problem here, so we're not done. We need to label that answer. Go back and see. We defined X to be our pounds of peanuts. So we are saying we need 60 pounds of peanuts in our mix. And the question was how much of each? So we also need to calculate 100 minus X, which is 60, to find out we need 40 pounds of walnuts. We want to make sure we label those answers on our word problems. Okay, number 3, we have a nice little radical equation here. We need to clear those radicals out. We clear radicals using exponents. However, before we do that, we need for one of these radicals to be alone. We need to isolate one of these radicals. We can start on either one. We can either isolate the square root of x or the x minus 3. I think I'll just go ahead and isolate the square root of x. So I'm going to add this radical over to the other side. And that leaves me with the square root of x equals 1 plus the square root of x minus 3. Now I'm ready. I want to clear that radical on the left. So in order to do that, I'm going to square both sides, raise each side to the power of 2. On the left, real nice, the radical and the exponent cancel each other. We just have x. On the right, you cannot just square each one of those terms. Remember, we need to actually FOIL this out, multiply it out, distribute it. However you want to think about it, you need to do the multiplication. So we're going to do 1 times 1, which is 1. 1 times the square root of x minus 3, which is the square root of x minus 3. And then we get that again, 1 times the square root of x minus 3 again. And then we get the square root of x minus 3 squared. Then we can do some simplifying there. These are like radicals, so they can be combined. We have 2 of them. So 2 square root of x minus 3. And then this last one, we get that again, that nice cancel again. The radical and the exponent cancel each other. So we just have x minus 3. Let's combine those like terms. On the right, we now have a 1 and a negative 3. So we have 2 square root of x minus 3 plus x minus 2 when I combine those two constants. I am going to subtract x from both sides. Now be careful, when we subtract x, there's still a 0 over there. We don't want to lose our equal sign. And then I'll add 2 to both sides. I'm going to come up over here to finish that. So I now have 2 equals 2 square root of x minus 3. Now the radical term is the only term on the right. So again, this time to get rid of that radical, again, I'm going to square both sides. On the left, 2 squared is 4. On the right, this is different. Notice over here we had a plus sign in the middle, so we couldn't just square each term, but here we have a product, so we can just square each factor. 2 squared is 4. Square root of x minus 3 squared is x minus 3. Again, the radical and the exponent cancel. We do need to distribute that 4. And then we just need to wrap it up, add the 12 to both sides. We get that 16 is 4x, divide both sides by 4, we get x equals 4. Anytime we have used an even exponent to solve, when we square both sides, we should always check our answer and make sure we didn't get an extraneous solution. So I am going to plug that in. You can kind of do it in your head. You can do it with your calculator. I'm going to write it out over here to the side. So we want to know, does the square root of 4 minus the square root of 4 minus 3, does that equal 1 for our check? Well, the square root of 4 is 2. 4 minus 3 is 1, and the square root of 1 is 1. So 2 minus 1 is equal to 1. That does check. So that is a good solution. Number 4, solve this quadratic type equation. That's a hint for us in the directions there. This is going to factor like a quadratic. If it's going to factor like a quadratic, we need to first start out by making one side of this equation equal to 0. So I'm going to subtract 12 from both sides. You might recognize this a little better if we remember that the square root of y is equivalent to y to the 1/2 power. If you write it that way, maybe you see it a little more easily exactly what's happening here. So if it's a quadratic type equation, we want to use u substitution here. So I'm going to say that u is going to be equal to y to the 1/2. If that is true, if I square both sides, that means u squared is equivalent to y. And then we'll do our substitution. This is equivalent to 6u squared minus u minus 12. And then there's something we can factor. 6u squared, let's try it out. How about 3u times 2u? 3 times 2 gives me the 6. And then 12, 3 times 4, 2 times 6. We kind of have to try and see what works for us. Let's try 4 times 3. And I think I hit it on the first try. 3 times 3 gives me 9u. 4 times 2 gives me 8u. The difference between 8 and 9 can get me that negative u in the middle. So I'll need a minus here and a plus there. You can factor in whatever way makes sense to you. That's just, I did a little trial and error there. That's just one method of factoring. Once we have it factored, we take each one of those factors and set them equal to 0. Here I'm going to subtract 4 from both sides. Divide by 3. Same thing over here, set this factor equal to 0. I'm going to add 3 to both sides. Divide both sides by 2. Now we are not done. We have the u is equal to some value, but remember our original equation was in terms of y, so we need to convert back into y. U was the same as y to the 1/2, or the square root of y. The square root of y equals negative 4/3. When we take the square root of a number, we always get a positive result. So this one is no solution. We don't get any answers from that. For our other one, the square root of y is equal to 3/2. That one, we can get a solution. We square both sides. And we find out that y is equal to 9/4. There's our final answer. And number 5, we have an absolute value inequality. When we're doing absolute value problems, whether it's an inequality or an equation, the first thing we want to do is isolate that absolute value so it's alone. So the first thing I'm going to do here is subtract 3 from both sides of this inequality. Once I do that, I have the absolute value of x minus 7 is greater than or equal to 3. Okay, absolute value and greater than. That's when we have our two inequalities. We need to rewrite this without the absolute value symbol. And when an absolute value is greater than 3, that's when we get the two tails of our number line. Either x minus 7 is greater than or equal to 3. That gives us the right-hand side. Or x minus 7 is less than or equal to negative 3. That gives us the left-hand tail. So we get these two different parts of our number line. Solve each one of these, add 7 to both sides. Be careful with your signs, especially on the next one. So we get x greater than or equal to 10. Same solve over here, add 7 to both sides, and we get x less than or equal to 4. This is an OR inequality. So again, with these two inequalities, we're going to get two intervals. Be careful the way I wrote it. This is actually the right interval, x greater than 10 or x less than -4. So we want to write that one first. Negative infinity to 4, square bracket because it's less than or equal to, union, square bracket because it's greater than or equal to. Anytime we have that equal to, we use our square bracket. There is our final answer. Your greater than absolute value is always going to give you those two intervals in your answer.